those equations on Monday. Essentially in the 2 days, every equation that you solved last year, we're going to review in 2 days. Yes.
2 days.
So you get like a real quick, hey, remember, this is how you solve this type of equation. So see if you can solve the warm-up. That is linear because there aren't variables in the denominator, but it does have fractions in it. So try and think like, what's the best approach to get rid of a fraction? Don't make it a decimal. Don't be like, that's the best approach. I'm just going to make it a decimal. Keep the fraction in the problem, but try and think, how could you work through it with those fractions? And there's a couple of different ways. Yes, making a decimal would be a way, but you can make your brain think a little bit too. With equations, there are always multiple ways to solve them, especially when we get to trig, you'll see that there's multiple ways. Make sure you click yes. Two. So these are together. Dylan, I'm going to pick on you. What did you do first?
Distributed the 1/4.
So, one of the things that you could do would be try and get rid of those parentheses. And he distributed the 1/4 through. So then you don't have to worry about what the parentheses do to the problem. You get them out. So 1/4 times x, 1/4 times -2 is just 2 over 4 or okay. Again, if you didn't do that as the first step, that's fine. But that could be one thing you could do to just kind of eliminate the parentheses. What's another thing you could do if you've got these fractions in the problem? Taylor? So, yeah, so she said she multiplied by 2, and you could multiply by 2. You're still going to have this as a fraction, but that would at least eliminate those guys. What could be a bigger number that you could multiply by so that you get rid of all of the fractions? If you look at the bottom, what would like that least common denominator be? 4. So if we want to eliminate the fractions all in one step, we can multiply by the least common denominator. When you're using a least common denominator to eliminate fractions, you multiply each one by 4. So this one needs to be multiplied by 4, the middle, this guy here, but also the 10 on the other side. You're allowed to pretty much do anything you want to an equation as long as each piece of the equation is affected the same way. So if I wanted to multiply by 50, I could multiply by 50, or by 48, or by 27, whatever I want to multiply by, as long as you're changing each piece of the problem. So if you do that, 4 times 3 halves, Connor, becomes
6.
6. Because I have 12 divided by 2. A fraction is really dividing. And then we got the x. Connor, 4 times a fourth is?
4, 1.
1, yeah. And then 4 times a half is?
2.
And then on the other side, 4 times 10 is 40. But by using the least common denominator, you're eliminating the denominator from the problem. And then you don't have a fraction remaining. So now I have something that looks pretty nice because I can add those together, take the 2 to the other side, and you get 6. Questions? So we're going to use the least common denominator fact to help us solve rational equations, because there's fractions in rational equations, but there's variables in the denominator. So if you look at example 1, 3 separate fractions, each of those fractions have a variable in the denominator. So we're going to try and use that least common denominator fact. But what do you have to do first? Just don't have everyone memorized yet. Mariella, okay.
We took AC group
factored form so that we can figure out what that least common denominator is. Mariella, do you know how factors?
It'd be x plus 3, x minus 2.
Nice. So the least common denominator would be the factors that you see in the denominator. Well, there are two of them. You got an x minus 2, we have the x plus 3. So if I take those two values and multiply each fraction by x minus 2 times x plus 3. Odette, do you know what happens then to this first fraction? When multiplied by the common denominator?
X minus 2 cancel.
Yeah, so the piece in the denominator cancels with the part that it has in common with the least common denominator. And then Odette, what do you have left? You have x plus 3. So then I have a plus sign. In the middle fraction, Odette,
You would end up with 3x minus 6.
yeah, so that piece is canceling. And then she said you end up with 3x minus 6 because 3 times x minus 2. God bless you.
Let's see.
On the right side, Odette, you just have
4.
4 because the denominator is the same as the least common denominator, so they cancel out. So again, fractions, gone by using the least common denominator. So now if we clean it up a little bit, combining our like terms, looks like we have a 4x equal to 7. So x is 7 fourths. How can you check answers when you have equations? You can plug them in. Any equation, you can check the answer by plugging it in. You also have a calculator. You can plug that into the calculator many different ways. You can use the calculator to plug it in. But you could also treat this as two equations. This would be y1. This side here would be y2. You can find where they intersect. You can go to the table of values and find when the x is the same for both of them as well. So there are many ways that you can check to make sure your work is correct. Or you can look at the answer that I give you on the answer sheet. That works too. But you don't have that for the test. Questions? So at the bottom it talks about that extraneous solution, an answer that doesn't work when you check it back into the original equation. That usually happens because we are adding expressions by multiplying, dividing, but you're adding extra powers to the problem, extra x's to the problem. That's why they generally appear. So see if you can flip the page over. We're going to solve another one of these fractional equations. So see if you can use that process again. Allie, what did you get when you multiply by the least common denominator? What expression do you have?
I got x plus 2 equals 3x minus 6 minus 6x.
And then when you get x's on one side and the number on the other,
I got 4x equals negative
so close. If you bring this 2 over, you have to subtract it.
Oh, negative 8.
There you go. Negative 8. So x is negative 2. Check it. Is it good to go? Yes? Is it alright? Emma? Why not?
Because when you plug it in, you can't have 0 in the denominator.
So when you get that answer, I know you hate actually physically checking it in every single x. At least check it in the denominator. Make sure it doesn't make that denominator 0. If you put it here, negative 2 plus 2 is 0. If we put it here, negative 2 plus 2 is 0. You can't have 0 in the denominator. It's undefined. It doesn't exist. So that means this guy is extraneous. Emma, what would the answer be then? There is no solution. So if I were looking at these graphically, again, y1 on the left, y2 on the right, if there's no solution, that means they don't intersect. That's why there's no solution. They're not crossing. So there's nowhere for them to have the same value for x. Question. So the other 2 problems we're going to look at today, besides solving, we are going to look at talking about x and y intercepts, and then we're actually going to see where 2 problems connect, like find that intersection point. So number 3 says find the x and the y intercepts. What kind of graph are we dealing with? Absolute value. So we got that v going on. So we're going to graph it last. We'll do the algebra first. What does it mean to find an x or y intercept? How do you find an x or y intercept? Listen.
You make the x or y 0.
Yeah. So x-intercept, you make the y 0. For a y-intercept, you do the opposite, you make the x 0. An intercept means where does it cross the x or the y-axis? So if it's crossing the x or y-axis, one of the values have to be 0. Which one would be easier to solve for? So look at the equation. One of them is easier to solve for than the other.
The y-intercept.
Yeah, why is the y-intercept easier?
So you don't have to like add subtract anything.
Yeah. Y is already by itself. It's already in y equals form. There's no adding or subtracting to get anything else by itself. So plug a 0 in for x. Combine some terms, and Abby, the y value would be negative 3. How do you write a y-intercept?
I gave you 0.
Nice job. So a y-intercept is a point where it crosses the y-axis. It's a point. So it needs to have an x and a y. So that's 0, negative 3. So now let's see if we can get the x-intercept. Doing the same thing except we have to set it equal to 0. So we have to solve these absolute value equation. What do you think you do first to solve the absolute value equation? Connor?
Split it into x plus 1 minus 4 and x minus 1 minus 4.
You are very close. We are going to split it, yes. But before you split it, we need to do one thing. Odette?
Did you move the 4 to the other side?
Yeah, let's move the 4 to the other side. And then we're going to split it. So we isolate the radical, we isolate the absolute value, you get it by itself, and then you split it. Remember, you're splitting it because there are 2 sides. So you have a left answer and you have a right answer. And the only way you can get both of those is if you take into account that there's a left and a right. So we use a positive 4 and then the negative 4. So we get 3 and negative 5. Any questions? So we're gonna graph this, we know it's gonna be a v. If you look back at the original equation that was given, this is one of the graphs that we reviewed on Wednesday. Where's the vertex? Thank you. Yeah, so we're gonna start this at -1, -4. Remember, opposite of h and k. So -1, 1, 2, 3, 4. It's supposed to be a v. If I go right 1, the absolute value of 1 is 1. Right 2, absolute value of 2 is 2, and so on. So first intercept, here's my y at 0, -3. Here's my x at 3, 0. And then if I move the other direction, absolute value of -1 is 1, absolute value of -2 is 2. I then can pick up that other intercept. So if we graph first, algebraically we can prove, verify that the graph is correct. Questions? So the very last problem that we're going to look at, kind of like a little bit of everything here. Still working with trying to like solve equations. But this one wants you to find the points of intersection. So now actually thinking, where do they really cross? And we have two different equations, graphically and algebraically, or algebraically and then graphically. X minus y is -4, x squared minus y is 2, -2. Think about how you would solve those algebraically. What do you think you'd do, Taylor?
I would probably do like for the first one,
Mhm.
add y to the other side
Okay, so add y to the other side.
to the like negative.
Oh, yeah. So then we would have, what, -4 plus y? And then what would you do with that?
Square it and then put it in the
Yeah, so, and do you know what that process is called? Begins with an S. Substitution, yeah. So you, when you have substitution, you solve for one of the variables, and then you take that equation and you plug it into the second equation that you're given. So she is solving for x. X is positive, you just bump the y to the other side. And then you're plugging this in, but she said you have to square it because the x is squared. So Taylor, if you square that, what do you get when you square that?
16
So close. There you go. So remember when you're squaring a quantity.
Why did you square the y minus 4 again?
Because when you plug it in for x, if I'm replacing x and I plug y minus 4
Oh,
in,
right, and it's x squared.
Yeah.
Okay.
it's x squared. So I have to plug that in and square it. Good question. Other questions? So if we combine some like terms here, we end up with y squared minus 9y equals 18? Or plus 18 equals 0, I should say. So Kevin, what would you do to find the y's here? How does it factor?
It factors. Oh, sorry,
It's
-3
okay.
and -6.
Yeah. So, is that your answer? Y equals 3, y equals 6. No? Why not, Quinn? What does a point mean, Quinn?
You have to put it like with the 0
sorry, I like lost my train of thought completely.
That's
It
it.
would be 0, 3, and 0.
You're close. We do have to write it with an x and a y, but it's not going to be 0 because we're not
Oh, so
finding.
we have to
Yeah, we got to plug them in. So we're not finding the intercepts. We're trying to solve. So we got to plug them in. So going back to this equation here, just going to write it as y minus 4. If you plug in the 6 quin, you would have the point 6 minus 4 is 2. So 1 point is 2, 6. What's the other one? We plug a 3 in.
Then it's
Negative 1. Questions? I think I'm out of time. I won't get to graph it. Sad. If we graph them, we would have a line and a parabola. The line and the parabola should intersect at those points 2, 6, and negative 1, 3. Questions? So your homework is back in the homework packet. There are some equations to solve. There's also a couple of problems that you'll be asked to find the intercepts for. Could I have 2 kind volunteers? Oh, Dylan. 4. And Odette, you'll do 9. So Dylan, 4. Odette, 9. Not Dylan, Jacob. Why am I calling you Dylan? Jacob, 4. I'm sorry. And Odette, you're 9. I apologize.
Oh,